All right, this video is about variability. Variability tells us the degree that the scores differ from one another if we had a data set full of scores. If we had a class of 15, for example, and we had 15 test scores, variability is telling us how the scores differ from one another, especially in relation to the mean. So like we had with measures of central tendency, there are measures of variability as well. Measures of variability tell us how the scores differ from the mean. So how far do they go from its central location? One way that we can tell variability is with range. The range is the spread of scores, so we can calculate that by subtracting the smallest score from the largest score. It is important to note that outliers can impact the range. So for example, if we have this first data set here, we can calculate the range, and we're going to take the largest score, so 10, and subtract the smallest score from it, which is 1, and so our range is 9. So this range is 9 different, the range is 9. Now, if we had the next example here, there is an outlier here. We have scores below 10, but then all of a sudden we have this 26. So the range still is the highest score, so 26 minus the lowest, and so now all of a sudden our range is 25. So outliers can impact the range like that by pulling it in certain directions. Another measure of variability is the standard deviation. Now this is the most common measure of variability. This is the average distance of test scores from the mean, or scores from the mean. This helps provide a sense of where a score is in relation to the mean. So to calculate the standard deviation, it does depend on if we have a sample or a population. If it's a population, we'll use sigma, the Greek letter, something like this, like an O with a little hat on it, sigma, to denote if it's a population standard deviation. If we have a sample, we just use a little lowercase s to denote standard deviation. Now, why standard deviation is so important. So if we draw a bell curve, and in that bell curve, we've watched the normal distribution video, we know that the mean there is in the middle. So let's just say, for example, we have a distribution with a mean of 30, and then each standard deviation is 10. Let's say we have a test score or something. So if we have a distribution like that, where our mean, or x bar, is equal to 30, and our standard deviation, let's say s as a sample, is equal to 10. This gives us a sense of where scores are. So we already have an idea of the spread of the data here, because our standard deviation is going from 3 standard deviations to the left to 3 standard deviations to the right. So we have an idea of the spread of the data, but we also can tell in relation to others. So we know most scores are going to be between 20 and 40, because that's what we know about normal distribution. 68% of the data is going to be in between 20 and 40. However, if we had a score of 55, if someone scored over here, that's over 2 standard deviations away from the mean. So that's an indication that, hey, this is outside of what we'd expect. If someone scored a 5, then that's way past 2 standard deviations, pretty close to 3 standard deviations away from the mean. So it kind of gives us an idea of how others are scoring and where that score is in relation to those as well. And that's why we take a look at standard deviation. And then variance is the last measure of variability. This is the average amount of variability in a group of scores. So we can take the average squared deviations of values from the mean. It's a fancy way of saying that it's standard deviation squared. Now, once again, oops, that is written incorrectly there. If we have a population, then it's going to be sigma squared. If we have a sample, it's going to be this little lowercase s squared. So it does depend on if we're dealing with a sample or a population and what we'll use to denote variance. And then if we have a variance of 0, then that means all data points are the same. If we have a large variance, that means our numbers are farther from one another and further away from the mean. If the variance is smaller, then we have a data set with closer set of values that are also closer to the mean. So both variance and standard deviation are related. There are formulas that you can find online if you ever wanted to solve them or by hand, so you can always look for those online. Thanks.